square root of 2 is irrational.
Prove it.
I will. Proof. Okay, so we'll prove it by contradiction. So what I'm going to do is I'm going to assume the opposite is true, and then hope to come up with something that doesn't make any sense. All right? Which means that my assumption was wrong. So we will assume.
Wait, you do that?
Yeah, you can do that. That's like
I think you could assume.
a really powerful tool when you're trying to prove anything. Is if you're trying to prove something is true, you say, well, suppose what I'm saying is not true, you know?
So to say you have to just prove it's not false.
So it's like you walk. Someone says, walks up to you and goes, "Man, Obama's the devil," and you could say, "Well, assume he was the devil, then he'd have horns. He clearly has no horns. Therefore, our assumption that he's the devil is wrong." Right? Does that make sense? Like that's how the proof would go, like in a funny fashion. That's exactly what you would do. So we do this all the time in our daily lives, probably, but now let's do it in a more formal way. Okay, so proof. We're going to assume the square root of 2 is rational. Now we got to use definition. What does it mean for a number to be rational? Okay, we have a decimal. That's a decimal expansion that's repeating or terminating, right?
Yeah.
But that's a kind of tricky definition. Let's come up with a better definition. What do we know about terminating decimals and repeating decimals? They all can be written as what? Fractions. That's the key. Any repeating number can be written as a fraction. Haven't I shown you that? How you can do that? Well, I will some other time. So, we can do that later. So basically that means, so by definition, the square root of 2 can be written as a over b. Alright, some number over another number, a fraction. So let's also assume a and b have no common factors. Okay, why do we assume this? Because if it's a fraction, I'm not going to assume it's like 2/4. I'd rather just assume it's equal to 1/2, right? Or I'm not going to assume that it's 4/6. I'd rather just assume it's 2/3. So we're going to assume that this is in lowest terms. Is everyone okay with that? It's not a big jump? Because if there was something like this, then you could reduce it to two other numbers, call them a prime and b prime, and that's your lowest terms. Right? So you just go with that. So let's assume this is true. Right? Then this implies, so I'll just say if and only if. This is true if and only if b times the square root of 2 equals a, cross multiplied. And that's true only if and only if b squared times 4 equals a squared. No, not 4. Lied. 2. Okay, and let's just to write this another way, 2b squared equals a squared. Okay, well, that means that a squared is a number that can be written as 2 times another number. So what can we say about a squared? A squared is even. Right? And every even number can be written as 2 times some other number. So like the number 2 is 2 times 1. The number 8 is 2 times 4. The number 10 is 2 times 5. Okay, so a squared is even. Well, if that's the case, then that means a has to be even. Okay, because think of numbers squared. Any number, if you take the square root of an even number, you have to get another even number. So like the square root of 4 is 2. The square root of 100 is 10. The square root of 64 is 8. But for odds, if you square odd numbers, you get another odd number. If you square even numbers, you get even numbers. So it works the same way backwards. So that means that a can be written, if a is even, that means a can be 2 times some other number. We'll call it c. Right? We just said earlier, an even number can be written as 2 times some other number. So we'll say, okay, a is equal to 2c. So plugging that into here, this means that 2b squared equals 2c quantity squared, where this 2c was A. Right? We just substituted. Everyone okay? Anyone lost? All right. So then that means, by simplifying, 2b squared equals 4c squared. And that means that b squared equals 2c squared. Okay. What does that mean about b squared? B squared is even. Which implies that what else is even? B is even. Okay, so, therefore, 3 dots. A is even, and B is even, which contradicts what?
The little box that you circled.
The fact that we assume that there were no common factors. Our assumption that A over B was in lowest terms. Okay? So look at that, remember that assumption right here? So you say, okay, that means they had no common factor, or they in lowest terms. Suppose it wasn't though, right? But then you could just reduce it and come up with a new A and B that was. So we're screwed either way. So there's a contradiction, therefore, all right, so that's a contradiction. So from that contradiction, the square root of 2 cannot equal a fraction, which means that the square root of 2 is irrational. Yeah, we did. Q, E, G. All right.